All right, good morning. So today we are going to do a little bit of a review for systems of linear equations. So a system of equations is just trying to solve two or more equations at the same time. So I want to review a system of linear equations before we get into some more algebra 2 stuff next time. So we can see here that we do have two equations. We have one equation, y equals 3x minus 2. That is in slope-intercept form. So you may remember y equals mx plus b. So m is the slope, and that is the coefficient of the x. B is the y-intercept, and that is the constant. So if my b equals negative 2, that means I'm going to go to negative 2 on the y-axis, and that's where we start our graph at. Slope is rise over run, so we think of it as a fraction. So positive 3 over positive 1, which means from that negative 2, I'm going to count up 3 units and right 1 unit, and I'm going to make another point. You can do that as many times as you want to. And then you're going to connect those points with a straight line. Try my best to get a straight line here. There we go. And you make sure you extend it throughout the entire graph. You don't just want an itty-bitty line. You want to be able to see exactly what's happening. Our second equation in the system is in standard form. We have negative 2x plus 3y equals 6. So when we are in standard form, it's a little bit easier to find our intercepts in order to graph. So to find our x-intercept, I'm going to take my x term, set it equal to my constant, and solve that. So I know my x-intercept is at negative 3. So I go to negative 3 on my x-axis and make a point. My y-intercept, I'm going to take my y term and set it equal to the constant. So y will equal 2. So I'm going to go to 2 on the y-axis and make that point. And then we're going to go ahead and connect those. Again, trying to get a straight line on here. All right, so to know what the solution is, we have to look at where those lines are intersecting or crossing each other. So that's taking place right about here. So I'm going to estimate, maybe it looks about 3/4 of the way through the box. I'm going to say it's about 1.75. And the y value looks like it's right about 3. So this is just an estimation. If you wanted a more exact answer, remember, we can graph these in the calculator. So if you were to graph this in the calculator, it would look like, let me get this picture for you. Where'd it go? This guy right here. So I'm not sure if you can see this or not. So let me just get this over here. So we have our two equations in there. So remember, you go to y equals, type your equations in there. The one that is in standard form, you would have to convert over to slope-intercept form first, but it would work. And then hopefully you can see right on the bottom here, the calculator will calculate the intersection for you, just like we did second trace to find our zeros and our minimum, our maximum in the polynomial and the quadratic unit. You can do that here as well. You just choose second trace and then choose the option that says intersect. So this is telling me my exact answer. So a better answer would be 1.71, 3.14. Or you could round that to the 10th, 1.73.4. I'd like to run you through another example. So again, this is a system of linear equations because we have two linear equations that we're going to be graphing at the same time and determining their solution, so where they meet or intersect. So again, my first equation is in slope-intercept form. I know my slope is negative 2 because that is the coefficient of the x. I know my b is 3 because that is the constant. So I'm going to go to 3 on my y-axis and plot that, and my slope is negative 2. Again, we think of that as a fraction because rise over run. Now, because this 2 is negative, we'll be going down 2 and then right 1. down to right one, down to right one. And again, you can do this as many times as you want to. As you've seen before, I'm not too good with straight lines, so I'm going to get as many points as possible here. Try to draw a straight line through all of these. Again, extended the entire way throughout the graph. My second equation, again, is in standard form, so I'm going to find my intercepts. Again, if you do not like finding intercepts, you can go ahead and take the time to convert this into slope-intercept form. So to find my x-intercept, I take my x term and set it equal to my constant. And to find my y-intercept, I take my y term, set it equal to my constant. And then I connect these guys. Okay, and again, extending it the entire way through the graph. So hopefully we can see here, despite my terrible drawing, that these lines are parallel. So because the system of an equation is where the lines intersect, there is actually going to be no solution for this system because those lines never cross. If you were to do that on the calculator, it would look something like this. We can see those lines are parallel and they're never going to cross. And if you were not able to actually see that, maybe you thought they intersected off the screen, if you want to try to find the intersection, you would actually get an error. See how it says error right there. So that tells you that these lines are indeed parallel, so there's definitely no solution. I'm going to show you one more example. In this example, both of our equations in the system are in standard form. So I am going to find the intercepts for both of these. So my x-intercept, again, take your x term, set it equal to the constant. There's nothing to solve for there. Y-intercept, take your y term, set it equal to the constant, and we get 3. So my x-intercept is -3, my y-intercept is 3. So I'm going to go ahead and I'm going to connect these guys. All right, my second equation, we have 2x minus 2y equals -6. So again, this is in standard form. So I'm going to find my intercepts. So my x-intercept, I take 2x, set it equal to -6. So x equals -3. And my y-intercept, I have -2y equals -6. So y equals 3. Oh, look, they're right on top of the ones we already have, which means this line is the exact same line. So again, our solutions are for where the lines intersect, which these two lines are hitting each other at every single possible point. So this is what we call infinitely many solutions. So if we were to do this on the calculator, let me get that picture for you. That would look like this. So we can see that even on the calculator, it looks like there's only one line available. So that means we have infinitely many solutions. If you are still confused with how to graph a system of linear equations at all, please reach out to your facilitator and we will work you through it. Have a great day, guys. Bye.